Alright, we now have the final video for the building and walls lesson. So the model has completed. We click close and then we can, let's see, we'll just let that start. Oh, it looks like our cursor's going away with us again, so I'll click save and that'll sort that out. And let's see, so now what we have done, if you see here, what we have done is we have run this lesson and it has all sorts of data in it. So we have already reviewed the channels and storm drain a little bit, and now let's take a look at how to review levees. So let's start with these error.check files because I think I missed some of those. Okay, so this one, I think actually this one was probably should not be there anymore because there's no longer a bank error. So if we were to compare this file time to the others, it might be, you might see that, yeah, 844. So that was not overwritten, so that no longer exists. We saw that in the when we fixed our levee. And these are, okay, that one, let me just reload these real quickly. And that one. Okay, and we already reviewed this one when we exported our data, but it's just telling you that these walls were adjusted to 1, meaning that they are now T-lines in the arf.dat. Nothing to do with that unless you want to replace those yourself so that you no longer get that check file. That would be your only thing that you might want to do. Now this one is called elevation. These are underground outfalls, so these would show you your bubble ups, and this would be your grid element elevation on the left and the invert elevation of your outfall in this column, and then this would be the elevation difference. So this one says, I'm not sure why this is coming up as a negative value, so we will be checking the elevations on those. But that should probably be part of the storm drain lesson, not the channel and wall, or sorry, excuse me, the wall and building lesson. So let's skip that and we'll put that back to the storm drain error.check. And again, another one, storm drain error.check and outfall.check go together. And you can see that, let's see, everything in here is a note, so that means that nothing caused a failure. If it has a failure, it will, in here it will say error. And so let's close these two, and then this is your error.check file. So let's see, there are potential errors in the arf.dat. They weren't errors, they were just values that were eliminated, and we already looked at them. This says, warning, the impervious area represented by the rtemp percentage is less than the ARF value for at least one grid element. That's okay. So what that means is that the rtemp is less than the building area. So then in that case, the rtemp will be reset to the building area. So that's okay. So the rtemp for those grid elements were reset to the building ARF value, which is usually 1. Okay, now this one is the levee.dat says, warning, the following grid elements have a difference in elevation across the levee or wall of more than 1 foot. This may affect the pressure head or the tailwater submergence, but may not be important in a large dam breach. So this is probably a warning that was more important if you are doing shallow overland flow and you have flow across levees that may be assigned as failure levees. And what it's saying is that here is your levee, your grid element with the levee, and this is the grid element opposite of the levee, and this is the levee elevation. This is the elevation of grid element 2167, and this is the elevation of grid element 2335, and the fail elevation and the crest elevation. So you can use this to kind of review your levees. But I don't really see a problem with this one because they're only a foot different. So I wouldn't say this one again, only a foot different. And those, if you noted, those buildings were about a foot higher than the streets and side. So that's not surprising to me. So as long as this doesn't go like say up to more than 2 or 3 feet, I'd say just ignore it. And so I don't see anything here that, oh, here's one that is um, about 3 feet different. So we can check this one out. But again, I don't think we'll be doing anything about these. All right, let's take a quick look at it though. If you take it here and you can paste it in here, and you'll see that, yeah, this elevation is, let's see what we got here. So that's 94. And then if you were to use this tool, this elevation is 91. So either this entire neighborhood is just much higher, or this building has kind of messed up the elevation of this grid element. Looks like it's probably the building because it seems 94, 91, 94, 91, 94, 91. So yeah, it might just be that the LiDAR in these surrounding these buildings wasn't interpolated very well into, because when you interpolate these buildings, I'm sorry, excuse me, when you interpolate LiDAR data into a high resolution elevation raster, you might get some kind of residual weird data across buildings. And let's take a quick look at it. We can just turn our elevation on. Let's see, where is our elevation data? Sorry about that. Yeah, you see that there's a bit of a jump up here. Let's take a quick look at our profile tool. That's this guy right here. And what I can do is just mix this with our Flow2D plot. And then I can add our elevation to our to our profile tool, and you would be able to see it right here. And then we can just click a line across there, and yeah, that looks like it is going up a little bit higher than it's actually going up to 1395 feet. Let's see what's happening to these guys. Now these guys, looks like they've just put these buildings up on a bit of a pedestal. So they might be valid, because look at that. You can see that kind of rise in elevation. So if you maybe got into your street view, you might be able to see that rise in elevation to pull those buildings up. And they're probably doing it to keep them out of a floodplain or something. Possibly, who knows. Anyway, so that seems valid. So that one would be okay. It is assigned as a failure condition. Not really sure why. It's probably just a random one that I selected for failure, but I don't really think that that would be failing. It doesn't look like overland flow would be flowing this direction or this direction, not like in this direction. So that might be something to consider, to just get that out of there for failure. All right, let's get back here. So I'm going to, the rest of the error.check is empty, so that means no more errors. It's funny that a bunch of, so many spaces are added in that. I should show that to Noemi so she can stop writing all those spaces. And actually this probably belongs in a file called levee check, not in error.check. And then somewhere down here you might see, oh my goodness, let's just get down here to the end. Yeah, okay, there's more stuff down here. Okay, then it says, yeah, potential errors in chan.dat, and this is just notes. Note, and it says the following interior channel element elevations were reset to the channel bed elevation, and this is for the ends of the channel. And this doesn't really matter because we're not doing any termination of flow on the channel anywhere. Our upstream and downstream channels are connected to an inflow node and an outflow node respectively, and our other channel connections are all set up by a hydraulic structure. So even though this happened, it doesn't matter because there's no termination on the floodplain for any of our channels. And this one says, yeah, these are all notes related to floodplain um, channel, floodplain to channel termination, and none of our channels need to exchange flow with the floodplain at the upstream terminus or the downstream terminus or the internal terminus. So they're all fine. You can ignore all of these messages. Initial abstraction. Okay, this is just a note about your infiltration. So if you have initial abstraction and you have a global tall. The global tall is 0.0042, and the infiltration data initial abstraction has already accounted for that by removing it from that data. No fatal data error inputs were accounted, and review the evacuated fplane.out file to see if to check for instability issues. Okay, so let's grab the evacuated fp.out. So I'm going to hit the E key, and here it is. Let's grab that with Notepad++. And it's telling us that this grid element had a number of evacuations. Let's go see why. Copy, and you know what? There's something in here I need to get rid of. Oh, okay. And paste. And oh, okay, right on the edge of the project. And again, it's a boundary condition, so probably don't even need that wall right there. It's probably causing some sort of wall failure or some sort of or something. You could probably take that entire wall out since it's so close to the boundary. So I would just suggest maybe remove these two walls right here, because they're probably not causing, they probably shouldn't be failing. So that would be one thing to consider, because that's along a boundary. And back in here, and what causes a floodplain to fail is that it might have a high slope between two grid elements. Sorry, I didn't mean what caused a floodplain to fail. It didn't fail, it evacuated, and it evacuated 5 times. So that means over a single time step, it was completely dried out 5 times. And that could be that it has a very high slope between itself and its neighbor, and it wasn't refilling between time steps. It was completely evacuating, it wasn't refilling. So if you get that and you're not on a boundary, you could increase the n value of the grid element right here, or you could give it a spatial tall of, say, instead of 0.0042, you could give it a spatial tall of something like 0.01 feet. And that would help stabilize that grid element so that it wouldn't cause your model to slow down, and it wouldn't cause instability or volume conservation errors. All right, what is next in our list? That is it. And that was it for error.check. And then channel elevation.check is a file where you have a left bank, or sorry, this would be the bank difference. How does this work? I guess it goes bank elevation and floodplain elevation, and then it gives you a difference, and then it tells you whether it's the left bank or the right bank. So my guess is it's taking maybe the higher of the two, or maybe it's repeating the data twice. I'm not quite sure why there's only one in here, since we have a left and a right bank. And this is your grid elevation. And yeah, that's odd. I wonder why it's only doing one. Might have to get Jim to sort that out. So, and there is a 1.25 foot difference. So this would be bank elevation minus the floodplain elevation. So if it's a positive number, the channel bank is higher. If it's a negative number, the floodplain bank is higher. And this would be telling you which bank it was assigned to. So how many we have in here, listed in here. Maybe that's, I don't know, maybe that's all of them. Maybe this is left and right banks. So unless you have a bunch of them where your channel bank elevation is much higher than your floodplain elevation, that could mean that your channel is perched up above your floodplain, and that would maybe prevent water overland flow water from flowing into the channel if it needed to. Typically these are sorted out when the Flow 2D runs, because when Flow 2D runs, it's going to reset this floodplain elevation to the bank elevation. And you can see they can become excessive, but let me show you why. So I'm going to copy this one and put it in here. And then you can see that this bank is all the way, sort of all the way down inside the channel. So our grid elevation right here is kind of skewed because it's in that channel. So I think it's okay for Flow 2D to just raise this up to the channel bank elevation, and then if the water were to share outside or into this channel, it would be doing it at the bank elevation, not this bottom elevation. So Flow 2D kind of sorts it out by yourself. So unless you see bright red holes in the depth data, I wouldn't worry about these. Or if you see a perched channel and the water cannot get into it, like say for example it was perched and the water was trying to come down here and flow over the bank and into the channel, and it couldn't because this whole bank was too high, then you would maybe worry about that. But for the most part, Flow 2D will take care of all of these. So if you see one that's really excessive, you might think that this one possibly needs an adjustment. So let's take a look and see if that one's really excessive and just needs an adjustment. And that one is not that bad. I mean, you could definitely adjust it back up here, but it's really not that bad. I'd probably just leave it as it is. And this channel is pretty, this is a pretty mild slope and mild bank. It's very uniform bank corrections all along here, so it shouldn't have any issues with that particular output result. Let's see, those are the check files. Now, and so nothing to do. Oh wait, let's take a quick look at the, so there shouldn't be any output data related to arf.dat, but there will be some output data related to the levee.dat, because with levees sometimes they fail and sometimes they overtop, which none of ours will overtop because they're walls, and you don't see a file called levee overtop.out. But looks like some of them have failed. 1, 2, 3 of them have failed, and so you can take that 5706 and put it into your 5706 and put it into your map, and you can see that, yep, that was that one with the grid element, or sorry, excuse me, with that evacuated cell too. So that must be why that evacuated, because the levee failed. And you can probably guess that that water is just getting trapped in here along the boundary, probably not really going to fail that one. So let's check the other one. The other one is 5878. 5878. And this one, again, same area. And there's not, I think we're just getting a lot of flow collecting in here. It might be raining and collecting in this corner. So, but it's along a boundary, so not quite sure why this one is failing. So something to look at. It just may be that this water has nowhere to go. So if you take a look at that one is 1413, 1412, 1411, 1411, 1412, 1415, 1414, 14. Yeah, so the water is flowing in this direction and it's collecting right here, and it's getting to 2 feet deep and causing failure. So maybe that one is going to fail, and maybe it has a hole in it that you could put in to, so you could check it on Street View and see if it has some sort of pressure relief in it to prevent it from failing. Okay, so let's grab one more. Let's see. Oh, sorry, here we go. And one more, 23732. 23732. And that says that this one might fail. So that is 1419, 1419, 1419, 1419. Now these are all, that's interesting because these are all the same elevation. So that's interesting that that one is getting 2 feet of depth on it and able to fail. So it looks like, and it looks to me like there's some lower elevations in here. So it may be that water is kind of collecting down in this area and collecting on this grid element. If you wanted to import your maximum depths and review this and your velocity vectors, you could certainly do that, but I think I'll save that for the mapping lesson and not do that for this review lesson. Let's try one more, or let's just look and make sure we covered everything. Okay, yeah, let's take a look at, no, I think that's basically it. Oh, here we go. And then there's a levee dot out and a levee deficit dot out. This is a mappable file, and we'll see that in the mapping lesson. And then levee dot out, I think it's just telling you which levees failed and when and what their water surface elevation is and stuff like that. So just some extra reporting data for those that failed. And that's pretty much it, just to do a review of that lesson. I'm going to save mapping for the final lesson, so we have put our hydraulic structures in, and then we'll look at our mapping.